Okay, so this says the side length of a cube was measured to be 15 millimeters with a possible error of 0.12 millimeters. Use differentials to estimate the maximum error in the calculated volume accurate to 7 decimal places. Okay, well, here we have a cube, picture of a cube. The volume is a cubed, where a is the length of a side, right? A by a by a. So let's write that out. So the volume is a cube. Okay, and we want to use, it says use differentials, so that means we take the derivative. So dV dA, I want to know how the volume changes as the side length changes, right? Because we're measuring side length and we want to find the air in the volume. Right? We got air and side length, air and volume. We want to know how volume changes as area changes. dV dA. So bring the 3 down, 3a squared. All right. Now we're going to multiply both sides by dA. Boom. So dV is 3a squared dA. So what does this mean? dV means difference. D stands for difference in volume. And over here, this stands for difference in A, side length. Okay, so the difference in volume is approximately 3a squared dA. So what is that? Well, the A, as it says up here, the A, the side length is 15. This is 15 by 15 by 15, right? It's measured to be 15 millimeters. But there's a possible error, and that's just real life engineering, things like that. They know tools are never perfect. Every instrument has its limits of exactness, and so it's precision, they call it. So there could be an error, it could be off by as much as 0.12 millimeters. So that's the DA, the difference in side length, right? It could be different by 0.12 millimeters. Possible error, meaning they measured it at 15, they measured with their tool and it came out 15, but they know that tool could be off by as much as 0.12 millimeters. So that's possible error. So that's the difference. So the actual side length difference in A could be up to 0.12. So plug that in, those in. So we're going to go, okay, dV equals 3. And then we're going to take that A, which is 15, and that dA, so plugging in that A right there, and then the dA right there, and that's the 0.12. All right, we're going to hit the buttons on our calculator. 315 squared, 0.12. So 3 times 15 squared times 0.12, I think it was. Was that 81? So 81, which is indeed the answer. So the cubic millimeters, because that's volume. The difference in volume could be as much as 81 cubic millimeters. Now, again, that's an approximation. It's not exact. It's an estimation because we used derivatives, which means we're really using a tangent line. Remember how we learned in this section? Tangent lines are approximately the same as the original real function. And when you're close to the original, and so if the A is 15, we're only off by 0.12. We're pretty close. So this is a good estimate. So there we go.